Alright, so today we're going to make a copolymer definitive socket with the attachment plate molded right into it in one procedure. Okay, first piece, 1/4 inch copolymer with maybe 3/8 inch hole drilled in the center of it. The hole is there for a vent, believe it or not, because these two pieces are going to be sandwiched together in the oven. When they're sandwiched, they're going to actually expand with the temperature and then slowly collapse one down on top of another, creating one piece of material out of two. Now, of course, since we're going to be welding them in the oven, these two pieces have to be very clean. We wash them with a biodegradable cleaner and then rinse them very well and dry them before we assemble this thing. Okay, so it's all in the layout. You got one piece with a hole first. The next part is going to be the plate. This is the plate we like to use because it's got a large ring in the center which will allow air to evacuate out. Okay, and we also, if you notice, it's got screws already in it. The flat heads of the 6mm screws are ground down just to expose the sockets for the Allen wrench. They can also be adjusted to properly align the plate on the distal end. The screws are reusable and used only as dummies. What we do is set the screws in a little bit deep because they're actually going to pinch the plastic as it heats. And by having that gap, that's what's going to allow the air to evacuate between the two pieces of plastic when it gets hot, okay? And we're going to do this all upside down, so now we're going to place the screws upside down, centered over that hole, okay? Then, the next piece is a round disc. The reason for this round disc of copolymer, all the same, in fact, it was cut right out of the corner of one of these pieces. The reason for this round disc here is to double up the thickness in the region where the plate's going to be, so the screws have something to insert into, and it gives you a better base of support. So it's actually going to be a 1/2 inch against the model and another 1/4 inch on the outside of the plate. So that gets centered over that, and then the final piece goes over that. Voila. Now, the top of the piece goes on. You want to help me or you want to just play? You going to work or you going to look at me?
Do you know what you're doing?
You know what I'm paying you for?
No.
To do nothing. Come on, get some bolts. Come over here.
You want my bolts there?
Yeah, I'll give you bolts. Get the bolts.
You know what you're doing?
Yeah, I think so.
Okay. But I don't think you're going to.
I don't think you're going to do it. Because you got to torque these down evenly now, too. Torque. Now watch. So that's how it's going to look. We're going to put it in the oven upside down. That should be centered on the ring. And that little hole there is going to allow the plastic to vent out between the two parts as it heats up. Now you can see the project hasn't reached forming temperature yet because the third lamination, that round disc, hasn't turned clear. Lowering the oven temperature values will allow you to heat all three segments without overheating the surface of the material. Now when the material reaches forming temperature, carefully lift it off the oven, position it carefully over the model, aligning the plate with the line of progression and the desired attitude on the distal end. As one technician achieves vacuum, the other is positioning the weight over the attachment plate to maintain proper alignment. After it's cooled, you can heat up a long-handled 6mm Allen wrench and melt it into the hex sockets to extract the screws. Now that we remove the screws, we're going to use a dual action sander with 100 grit paper on this to surface this, okay? Very simple, fast. And we're there. And again, we build the prosthesis on the model in an inverted attitude. this harmony has to be standing pretty much vertical. So we're carrying the line, so there's your flexion contraction built in. Now we're ready to continue with this to pile on.